Hello and welcome to another video. In this video we're going to be working on longest ideal subsequence. And in this one you're given a string s consisting of lowercase characters and an integer k, and a string is ideal if the following conditions are satisfied. T is a subsequence of s, and the absolute difference of every two adjacent letters is less than or equal to k. Return the length of the longest ideal substring. So they tell you like there's a subsequence here, which basically means for every character you have the option to take or to not take the character. And for problems where you have a take or not take, it's usually best to do dynamic programming because you basically have an option every time. Do I take the character? Do I not take it? So let's go through this thing. So the best thing is ABCD here. And the second one, you can just take everything. So basically, when trying to determine whether to take or not take a character, keep in mind the string is 10 to the 5th long. So what things do we need to know whether to take the character? So we need to know, obviously we need to know like the index of what the character. And then the last thing we need to know that's going to make it as small as possible is the previous character, right? So if we have this like A, C, F, G, B, D, and we took A, then for C, we know we can take it, right? But if we took like A and then we're on F, then we can't. So those are like the main things you need. And so for this, you can basically write a recursive solution where you keep track of these two things, and then now we can come up with like all our states. So what are like some of the possibilities we can have here? So obviously like, well, I guess let's write down everything. So state is index previous character, and then what's like the base case? So the base case here is pretty simple as well. It's just going to be out of bounds, right? So if we're out of bounds, we just return 0. So that part's pretty easy. Like we went through the whole string. Okay, and then now what's the recursive case? So the recursive case, you can kind of break it down into two different types is what I did. And I think that's like the easiest. And so recursive case A is our previous character. We haven't used anything. So let's just call maybe we'll symbolize that as like null or something. So if our previous character is null, then we have the options of take character that we have or don't take. And if our previous character is something, then it's kind of similar, right? So we can take this character if difference is less than or equal to k, right? So the previous character and our current character, the difference is less than k, or we can just not take as well. And that kind of breaks it down to all the things we need. So we can kind of walk through this. And the other thing I noticed, at least in Python, when I did this in Python, is this actually failed. Like I got a memory error when I did this recursively with these two states, which should pass because it's like 10 to the 5th and 25th, so that should be small enough. But because I got a memory error, basically the fix I needed to make was, since my memory was too big, you can actually get rid of one of these states. Because essentially, and I'll kind of show you in the code, because the recursive case will always go to like the next index. So I'll show you that in the code. But essentially what you can do instead, so I'm going to show you this in like a bunch of different languages. So let's start out with this Python solution here. Let's just go down here. So this is like what we just talked about. Let's just do this. So essentially it's just a basic recursive solution where you have, an index and a previous character, and then this is your base case where if you're out of bounds you just return 0, and this is the case where we haven't taken any character, so then we can either take this current character, in which case our last character will be this current character, or we can just keep it as null again, and then we just go to the next index. Otherwise, if we do have a previous character, we can always not take the character. And if the difference between this current character and the previous character is less than or equal to k, then we can try that as well. And so that will just be 1 plus dp vi plus 1, and then our new last character is going to be this current character. And notice every single recursion goes to I plus 1. So this is why I meant we can get rid of this state. And then if we had a memory error, it means our cache was too big. So we can make our memory just go into this. So let me show you how first, and then I'll show you the solution. So because every single recursion goes into like the next index, we can essentially do a bottom up DP and get rid of this. And I'll show you how. So first we can start with, and I'll show you this with a dictionary, and then I'll kind of briefly talk about how I use an array, but I think a dictionary is easier to visualize. So let's say we have a dictionary here, and then we'll have a new dictionary like this. So this will be DP, and then this will be, and you can use this template for like all bottom up problems for space optimized bottom up. So what we're going to start as is we're going to have a dictionary with keys being the previous, like the last character of all the words we have so far. So in the beginning, and let's just write down this word as well. So let's say our word is this first one. So A, C, F, G, B, D. So in the beginning, before we have any letters, like this is completely empty, right? And we start here. Then basically what we're going to do is for this index, we're going to say, okay, we're going to take every single character that was in here. So this is just going to have like, the key will be the character, so it'll be like A, and then the value will be the length of the word that ends with that character. So right now it's empty, so there's nothing there. So because there's nothing there, all we can really do here is just either use this A or not use this A. Right? So if we use this A, then our character will end with A, and it will be length 1. And if we don't use this A, then we have nothing, so we don't have to worry about it. Then what we do is we take our new DP, and we put it into our old DP, and then we reset our new DP. So this is going to go like this. And then we move over here. So now for our C, we can add the C to the A, right? So if I add the A to the C, we'll have the word AC, in which case that word will end with C, and its length will now be 2. Or we can just have a brand new character again, like this. So except now we don't need to have this twice, because if we have this like this, you don't really need it, right? Because you already have another character. So like this is always going to be better, so we don't need this one. Okay, so basically, and I don't think I even did this with the code, but it doesn't really matter. I did do a maximum, so this would take care of it for you. But essentially, yeah, you just go through all of these values, and then you see, can I add the C to them? And then if you can, then you put in the result here, and then finally you just have the result of having the C by itself. Okay, and I forgot one more thing. So, and we also have to go through all the characters in here as well, and like what they would be if I don't add this character, right? So for every character in here, we can either add the C or not add the C, and we can have the C by itself. So the C by itself is obviously never going to be used, but we can just have like this, right? So we can have A with 1 still. So now same thing, we take our thing in new DP, and we put it up here. Then we go here. So for F, we can't add it to A, right? Because the distance is too big. And we can't add it to C either. Can we? Let's see. No, we can't. Yeah, because they tell you it's 3, right? It's C, D, E, F. So you can't add F to any of these. So the only thing you can do is just have F by itself. And we can still have all these other characters. So basically these would just get copied down into here, and then we'd have an F as well. And then all of that gets copied up here. So essentially we'll have something like this at the end of this iteration. Now for G. So for G, we can add it to F, and that's it, right? So we can have G. So it'll end with G, and our string will basically just be FG. Now this is length 2. Or we could have G by itself, but this is better than G by itself, right? So then what's going to happen again is we're going to copy all of these down here. And this is just like all of these without adding the G, and then we're going to copy it back up. So this will go up here. Then for B, so we can add B to C. So that means the string will end with B. It will be length 3. We can add B to A. That means the string will end with B again. It will be length 2, but this is better. And can we add B to F? No, we can't, and we can't add it to this. So it would just be this plus all of these, which means the B just gets moved up here. So maybe there are some more optimizations I could have done, but honestly, this is a problem where you can do like a bazillion optimizations. But I think I'm pretty happy where I got it. So here, last one. So we can add it to the C, which will give us D with length 3. We can add it to, no, we can't add it to A. Can we add it to F? So D, E, F, yeah. So this will be D with length 2 if we did that. We can add it to G, right? So actually, can we? No, we can't add it to G, and we can't add it to B. So it's literally just this. So I do think there is actually an optimization where you basically just, like, you're only going to be adding one character all the time. So I don't think you need to do this copying, which I did. So if you want to like redo some of the code I did, you're basically going to only be adding one thing at a time, and then the rest of the stuff you're going to be copying down. So what it's gonna look like at the end is it's gonna look like this in my code, and then I just bring this up. It doesn't matter too much, but yeah. So then this is your thing at the end, and then you just return. Oh, I think I screwed something up actually. Let me go back. Yeah. So so you can add it to B, right? That's what I screwed up. Yeah, so you can add it to B. So this D will be length 4. Because you can add it to C, that will make it length 3. You can't add it to this one, and you can add it to this one, and that'll give it length 4. So it'll be like this. And then that would be your answer. So essentially, you just only keep like the letter and what's the longest word you can make with it. And then for every iteration, see, can I add it to all of these again? And that's pretty much it. And if I can't add it to any of them, so let's say my letters are like X3 or something somehow. I mean, this is probably never going to happen, right? Because how do you have X3? Let's say I have like X1. Or actually, no, you can't have X3, right? Because you can have like XYZ or something here. So yeah, you can't totally have this like Y3 or something, whatever, Z5. So let's say I try to add this D. If I can't add it to any of these, then I'll just put it in like this as just the one letter. So that's basically it. And you can also do this with an array. And the way it works with an array is pretty simple. So you take your character. So instead of this like dictionary, you can use an array. So you take your character. Let's say your character is like D. You can subtract the value for A, the ASCII value for A, and then you'll get like an offset. So you'll get like DCBA, right, which is going to be like 4. Because this D will be some number. Let's call it 97. It's not actually 97. And then if D is 97, A will be like 93 here. And then you'll get an offset. And so this is basically like the index of your character. So when you have an array, you'll just have an array of 0 to 25, which will be like the index of the character. And then you can go through the array and figure out where like all those characters are, and I'll show you that in Java. Well, let's look at the solution first. This is basically what I was talking about. You make a dictionary. I do think you can optimize this a little bit, but essentially this is what I was talking about with bottom up. We can just get rid of, notice in here, we're not storing an index anymore. We're just going through the index and just making a new set of letters every time. So this is basically that. So you make a DP, then you go through your string, and you get its character value. So I showed this as letters, but you can just get an ASCII value instead. And then store in a dictionary's ASCII values. So you make a new dictionary every time, and then you say the default for this new character. So whenever you make this new DP, and I didn't show this either, so whenever you make a new character, let's say I'm putting in D, I'll just say like D equals 1 as a default. Then I'll go through all of these and see if I can make it better. So I'll just like try to add D to all of these, and if I can get it bigger than this, then I'll update the value. And so that's basically this. So if I can make it better, then I'll make it better. And then also go through all the old DP and copy all the values down. And I do think like this can definitely be optimized because you're essentially doing like 2 or 3 times the work. But either way, that like it's still going to be O of the same thing. And then at the very end, you just make your DP equal to your new DP. Like I said, you have all your values here. You just bring them up here. And this one passes. This one does not. So if I actually run this one gave me a memory error, which is kind of weird for a medium problem. But yeah. Maybe I did something wrong. And then if I run this one, and I'll include like all these solutions if you're interested. So this will show you like memoization, bottom up, and I'll show you Java one as well. So yeah, so you can see it's like pretty slow, which is also interesting. It is faster like using arrays. So here's the array solution. And so let's look at this one. So we have our DP, which is an array of 0 to 25, and the index will just represent like the letter. So like I said, it's pretty easy to get the letter. You just do whatever letter you have minus a. That will give you a number. And then we have the new DP again, which is the new array. Now you can also optimize this. You can probably not copy stuff down, but even if you did need to copy stuff down, you can optimize this further by, let's say your array needs to be 26 values. You can just make an array of 52 values and then kind of like use one half to update the other and back and forth and back and forth. It's a little bit confusing. Maybe I'll do something like that in the future. I mean, it doesn't really add too much. Like this is the main thing. But yeah, essentially the same kind of thing. So you get the offset of your value. So just your letter minus a, convert that to an int in Java. It's a little bit more convenient. So you just take your letter minus a, this will give you some integer value, and then when you convert it to an int, that'll give you the index in the array. And then the default is just, let me just use that one character by itself. And then you go through your original array, and you just say like, okay, for every single letter, if I can use the letter, let's see if I can make this value bigger, right? So like if I'm on, letter D, I first make it 1, and then I go through all these and say like, can I find something better to make it not 1? Can I make it better? And then, yeah, I do copy it down, but like I said, you can probably optimize that a bit. But yeah, this is within an array, so it's like, it's basically all the same thing, except it's just an array instead of a dictionary. And then at the end, so you can get a max of an array using a stream. So you can just do like array stream DP, and this gives you an optional integer. So you have to give it like a default value. So I think if you give it like an empty array or something, it won't give you anything. So you just provide it like an empty value, which will never be hit in this problem. So it doesn't really matter. But if you don't provide it, you'll get an error. So yeah, we can run this. And yeah, I didn't want to code it up because there's like so many solutions, but this is like reasonable. Still like not as good as I want it to be, I guess. But yeah, I think the optimization that I probably need is not move stuff down looking back, like because you're only getting one new value really every time. Like you're only just getting how much you can get by adding the current letter, and that's it. So you can go through all of your, yeah, in fact, we can probably even code that. So we can literally just go through this whole thing, calculate this value, and then update it back. So let's actually code that part of it. So let's not use the new DP at all. And we don't need this at all. And we can just say, so we need basically a current value, and we need like a current total or something. And we'll just say that's 1, right? Just by using that one letter. So if this is true, then we can just say current total equals mathmax current total or dpj plus 1. Now we don't need any of this. We don't need any of this. And then all we need to do is just update the array at the very end with this current total. So we go through all of these. This needs to be here. And I think this is like the much better way to do that I didn't do in the other stuff. So you can just say dp current total or current value equals current total. And I feel like this will work. But this is not something you can replicate in like most other DP problems, which is why I also didn't do this. Like the previous solution is you can use it for like almost all problems, but this is like specific to this one. So I think this will work. Yeah, I mean, it's a little bit faster. And now we're not like updating our array every time. We're just reusing our new array. So essentially we're reusing our new array. We're getting the value, like the biggest value we can with this letter, and then just updating it back in now instead of using two arrays or 2 dictionaries or something. And I'll update the Python code, I guess, to do the same thing. So I guess that's like the best thing to do. But I'm still kind of surprisrised that the memoization solution failed. But regardless, yeah, so we can talk about time and space and be done. So this time is O of n times 26. You can probably do more optimizations. I don't think it'll matter. Like let's say your character is ASCII or your offset is like 10 and K is like 2. you only have to search for like 8 through 12, so that would save you a little bit, but whatever. It's not a big deal. So this is like n times 26, and then space is just 26. So we got rid of the other dimension. So it's probably pretty confusing to most people for a medium problem. Hopefully it was reasonable. And let me know if you have any questions, and I can explain stuff further if you want. Thanks for watching.